In this video, I will demonstrate how to use our code and how to call the new interface to predict our situations. We connect to Google Colab and upload our database file. Next, we need to preprocess the data. First, we need to deal with missing values and outliers. After previewing our dataset, we select the columns we think need to be processed and use the interpolation method to perform median interpolation. For the data set we selected, the data values are clear and the indicators are obvious, so there is no need to normalize and standardize. After that, we need to perform feature selection by analyzing the feature correlation of the data. We draw the correlation matrix and heat map, and use the random forest model to sort the feature importance to screen the features with high correlation with the results. Because all features have high correlation and importance, we select all features. Next is the EDA part. Each attribute to be analyzed is plotted according to the different outcomes to understand the approximate range of each attribute. From this box plot, we can know the approximate distribution of each attribute when it comes to whether or not a person has diabetes, and can therefore conduct preliminary screening of patients. Next is the model building phase. First, we import the libraries we need. Define features and target variable. After separating the training set and the test set, we can train each model and get their accuracy. In order to combine the advantages of multiple models, we designed a voting classifier. It can weightedly combine different models through soft voting to improve the robustness of the model. In order to ensure the robustness of the model, we also choose to use k-fold validation to prevent the variance of the test from being too large due to overfitting. We choose 10-fold cross-validation to get a new prediction accuracy. After the test, we print out the training and test results. Here, we can see the indicators we need, and we predicted confusion matrix. draw the ROC curve, we define an evaluation function. Here, we extract the part with a prediction result of 1 and get the AUC ROC value. Next, in order to make a user-friendly interface for medical personnel to use, we can write a Python program that can pop up a new window to allow us to submit our dataset and use the trained model for prediction. First, we need to install the Streamlit library so that we can create a new interface. Next, we need to write our Python file. After importing the required libraries, we can set the title, load the model, upload the data file, preview the dataset file. In this way, our Python file is compiled. Run this string of code to run our compiled Python code on Google Colab. We see that a confirmation question pops up here, and we enter Y for yes. A URL pops up here. We click enter and then jump to a new page. We enter the address here and we can enter. Here, we select the dataset for our test and click the prediction button to use our previously trained model for prediction. In addition to the prediction results, we can also compare the classification results of the voting classifier, the LGBM, and get the metrics of the two models. If you need to save it, you can download the results as a CSV file. That's all. Thanks for watching.